Well, welcome again to the afternoon sessions. I'd like to invite up onto the stage former distinguished engineer Kelsey Hightower. Kelsey gained an interest in computing at a young age, opening a small consulting shop just 20 years ago, before passing through the halls of Google, Puppet Labs, New Relic, and CoreOS. Kelsey is a system administrator by trade, a programmer by necessity, but a problem solver at heart. We're really thrilled to have Kelsey join us today to talk about data and the future of databases. The first question I've got to ask for you is, what are your thoughts on what was introduced today and what that means for data going forward?
Yeah, I mean, I'm probably like a lot of people here that are new to SurrealDB. And I remember when we got on the call, you invited me. I was like, so what do? You said a database. I'm like, why does the world need another database? There's plenty of databases. And so I'm sitting in the audience. I'm probably 7, 8 rows back, and I'm looking like, if they show me some queries, I'm going to be a little disappointed. But the thing I think you showed that it made it interesting was the realization that every decade or so, we start adding new technologies to fill in gaps that we have. If you started when I started, you had a database, you put everything you could in it. And then the web came along, and then you brought in Redis because your database just couldn't handle the load. It wasn't just because the database couldn't handle the load, it's because disks were slow back then. Memory was small back then. And so we did all of these best practices as trade-offs to the limitations of what we had. And so then caching became a best practice. And depending on what you're working on, maybe a graph database became something you had to add to the mix. And before you know it, you have 5 or 6 different database layers. And if you're a good developer, what'd you build? A data abstraction layer. So that no one had to see that data was spread out across all of these things. And then worst case, you had this ID that related to some other ID in some other system, and you hope that you never got it wrong. And so every 10 years, we go and consolidate all of that stuff. And what I saw in some of those queries was the consolidation that this isn't just a database, it feels more like a data platform, right? And I came from an industry where in systems administration, people wrote shell scripts, config management, Docker, and then we got Kubernetes. And Kubernetes represents a consolidation of a lot of ideas into one singular system. And it feels like now we're seeing that trend carry over even to the data layer. And this is not necessarily new. I learned Swift programming not too long ago. If you ever use Swift data in the iOS world, they abstract away a lot of these data concerns for you. So what I saw in the keynote was more than a database. I think that doesn't do justice what we saw. I actually saw this data platform that allows people to consolidate what used to be best practices into a singular workflow.
It's tricky, isn't it? We asked ourselves internally whether we should be calling ourselves a database, a data platform, whether is this data engineering as a whole. The way we saw it was sometimes data platforms are run in the cloud, you can't bring them down onto your device, you have to use the service in the cloud to do that. And we wanted to, it's an interesting point, we want to ensure that SurrealDB can be used in many different ways, in continuous integration, in embedded, in the cloud as well, in due course. I guess what is, in your mind, what is the differentiation between a data platform, a data service, or a database?
I worked in the cloud for almost 8 years. And what I witnessed was things like Prometheus, things like Kubernetes. These were some of the first cloud systems that were built to scale down. Even when I was at CoreOS working on distributed systems, one key element was it needs to work on a single laptop. You need to be able to run whatever system we're designing, has to be able to scale down as well as up. And it turns out when you build a system that can scale down, you usually end up with a better design. When you can assume things like, hey, I don't know if people remember Cloud Foundry back in the day, but it was designed to be run by larger teams. I remember following the documentation. It's like, hey, welcome to Cloud Foundry. You can follow our Getting Started guide. I'm rubbing my hands. It's like, oh, we about to get Cloud Foundry. And it said you needed 30 VMs to start. I'm like, 30 what are you doing with 30 VMs just to start? Where we are now, these programming languages, whether it's Golang or Rust, they scale down pretty well, get pretty good performance, and we have enough distributed system protocols that can be used as libraries where you can scale back up when you need to. And so when I think about this idea of a data platform, the reason why I'd say it's a data platform, we've learned too much in the last 20 years to keep resetting the table with just faster and better. We don't need 10,000 instances of Postgres. But what we do need, though, is to take all the things that are hard to do. I think people like yourself, like myself, and many people in the audience, you've worked at large companies that had to figure this stuff out in production. But one thing we failed to do is turn those things into libraries that everyone can use. So every company you go, you implement the same thing over and over again. This era of computing, the products that are launching now, you can tell how much experience the founding team had based on the APIs that it presents. And so the fact, for example, the thing that really made me lean forward today was people are training ML models. If you ask people, what do you do at the tail end of that? Most people are confused. They have no idea what you do at the end of an ML process. All people do is say magic. The truth is, you're just creating a snippet of logic that most developers will just call like any other API. That's what you're doing. We're going from symbolic programming, if, else, then do this, to this thing where we're going to get some fuzzy prediction, some score that your business is comfortable with. How do you integrate it? Most people haven't figured out that on the library side, and you tend to need data to make it work. So why not put that logic in the database? So if any developer said, hey, why would I even look at something like SurrealDB over what I already have? And you show them that workflow, that there's this model that you can now attach to this database and create a whole insert thing based on it, and it uses the data that comes back from the query, and you can just make a prediction, that will blow people's minds. So I definitely think it's on the platform side because it allows people to actually do things with their data versus just inserts and CRUD operations.
That's really important. And that brings back to a point you made earlier. So the one thing we get compared to a lot is performance. You know, how do you compare performance-wise to Postgres? Is this right for me to be using this in terms of Postgres? How do you compare to Neo4j for performance on the graph? But I think a lot of people fail to remember that actually when they're implementing these different technologies as an alternative to SurrealDB, they're implementing a document database, a time series database, a graph database, a full text search engine. And they're combining that all together in an API. That's got to sit in a distributed environment. It's got to have business logic in the API. And people forget to count all of that performance aspect together as well. I've got two questions, I guess. One is how much functionality and business logic should sit within the database, and how does that affect developers?
Well, one feedback that I gave the people working on SurrealDB is that you got to make this snippet of logic first-class entities. They need to be artifacts that can be versioned. There's a lot of value that we've gained in the software world, right? If I go download SurrealDB as of today, I should be able to download 1.0.0. And then when 1.0.1 comes out, there's going to be a very easy way to upgrade that and go from one version to another. But what we all, at least I have, got burnt in the past, have you ever seen a company that has a bunch of store procedures? No one knows who wrote them. No one knows who put them there. And I remember working with the Oracle DB, I was like, hey, dev isn't working like production, and I kind of need it to so I can fix the bug. And so I think we're missing some stuff in the dev database. He's like, what are you missing? I'm not sure because it's a bunch of store procedures. And I sat by them, and what they did was they dumped the store procedure from production, and they did a diff with the one in dev. I'm like, my confidence in us ever getting this stuff to stay in sync has just dropped to 0. Because there are no diffs, there are no versions, there is no way to have any certainty of reproducibility. It just works, maybe. And so when I think about all of this logic, I think one thing you have to do is you have to make these things first-class citizens. You have to be able to say, we are running this database with this data set, with these snippets of logic. And so that way, if I want to go and move things from production, I don't have to use the database-specific migration tool. It would be really nice to be able to have a package manager list out all of my dependencies to make my actual system work. So I think a lot of people are hoping that it becomes easier to manage these systems going forward. I think in the next 5 to 10 years, you will have a scale-up thing that you can't do on a single laptop. And that scale-out thing will probably tackle some of the performance concerns. But a lot of people keep comparing their situation to Facebook. You probably aren't building something that will have 2 to 3 billion users and 100 million concurrent. You ain't doing that. Most people that make this concern, like, how many users do you have? It's like 300. 300? That's one VM territory for everything. So I think a lot of times people have not thought about the network hops. In the cloud, the biggest part of your bill will be the network. If you're using Elasticsearch, you're using a load balancer, and you're going across multiple zones, I bet if you look at your cloud bill, networking is probably the biggest thing. If you do the math, let's just say you're fast, 100 milliseconds between all of these systems, you're going to be at 2 seconds. You got to go to Redis, key isn't there. Go to your database, it's not there. Oh, for this part, I got to go to search. You're already a second and a half in just to fulfill that response. So I think people have always been trying to consolidate these layers. Now I think the question is, should we put it there? And so please don't repeat the mistakes of Oracle and have a bunch of stored procedures that become spaghetti code. Figure out a way of making that logic first class and artifacts. Then I think the developer story will be great, and the operations story will be great. And I think you got to make sure that that's good as well.
There's a balance between highly scalable and highly available. There was that interesting article from DuckDB a few months ago saying, I think it analyzed Google Cloud big table or some database in Google Cloud with a spanner. And it's actually, the majority of people don't actually have more data than sits on a single node. And very few people have more than that. Now, obviously balancing that with the availability aspect of a distributed system. But for SurrealDB, I mean, where do you think that line should be drawn between putting a database in Kubernetes, but also how people are building applications today, which is, we've gone from a single large server application all the way out to thousands of microservices. Some people have taken it a little bit too far. And then, so with SurrealDB, we're saying, look, you can come back, not fully, but to this platform, to this ecosystem that enables you to do things more simply. But where do you think that line should be drawn?
I remember like 5 years ago, someone was like, Kelsey, I have MySQL running in Kubernetes. I was like, you're going to lose all your data. And they were like, why? What's wrong with MySQL? I said, nothing's wrong with MySQL. It's just that Kubernetes, if you just rub Kubernetes on MySQL, it doesn't turn it into RDS. That's not what actually happens. Kubernetes doesn't make any assumptions about an application. At best, it will place it on the server, and you better hope the data's there. If the data isn't there, Kubernetes will happily start your database. Hey, your database is running, and you make your query, and you're like, where's the data, though? Kubernetes is like, that's not my problem. So Kubernetes can only meet you partial way. And the way those databases were designed, they were not designed for distributed systems. It's just how it works. CockroachDB, maybe. Elasticsearch, maybe, depending if they have built-in cluster management or not. But what people are trying to achieve with these things is ideally, we separate compute and storage from each other, so that way we can get these highly performant and scalable databases. But even then, all of that is an intermediate step. If you look at the progression of CDNs, for example, anybody remember Real Media Server? Like if you wanted to stream something, you got like the Real Media Server. I'm dating myself here. There was no YouTube then. But if you wanted to stream something to like 10 people at the same time, you got a media streaming server. And you set it up, and ideally you didn't have that much bandwidth, but you just had a better codec and compression to stream things to people. And if you wanted to host images, you could have used FTP. If you're really in financial services, you use SFTP. But either way, we were sitting here trying to serve images to the world from one location. And then CDNs became popular. And if you've ever used a CDN, it's just mind-blowing. You put your image, and this thing optimizes that image for distribution around the world. I think people want databases to be that way. At some point in the future, it would be nice to get a location with permissions and say, store this data only in Germany as part of the query. And the database platform itself will say, hey, I know where the data is sharded around the world. I know how to protect your data based on these laws and regulations. Give me that query, and I will make it so. So that can be part of the data constraint. It's physical location. So I think most people want to go beyond just being a DBA part-time. I think people want to evolve these systems. So yes, it's great if it runs on my laptop. It's great that I can run it embedded. But also there's going to be use cases where I need this thing to run globally. And I don't want to think about read-only replicas. I don't want to think about database sharding. These are things that are really hard to do, especially when it comes time to reshard a database because you got it wrong. This stuff is hard. And so we hope that databases mature to the point where I just say, here's my data, here are my schemas, and I like to be able to refetch it in a reliable way. That, to me, is the end game that I think something like Surreal Data, if you want to go surreal, you want to blow people's mind, you got to make it feel that way. Scale down, but then scale up and make it feel the same.
Yeah, absolutely. While I ask my next question, we'd love to answer any questions that are from the hall. So if anyone's got any questions to ask to either of us, then please feel free. We can't actually see you, so perhaps we can get someone to, there you go. If anyone's got any questions, but in the meantime,
any question is fair game, by the way.
On any topic, databases, Kubernetes, clusters, scaling,
whole nine.
Anything.
Oh, awesome. I can throw this at people. Who's going to ask the first question? Cue it up. Raise your hand. There we go. I'm going to look silly as I throw this, OK? So you got to catch it. You ready? Look at that.
So, I had a question.
You got to use the thing I threw at you.
Okay. I know, just catch it. But sorry. So thanks for. Sorry. Can everyone hear me now? Yeah. All right. I think I had a question more around. So you mentioned about, and this is more towards Kelsey, which is you mentioned about how we keep needing these new technologies every 10 years in the initial question that came in, and how we sort of see a shift in the way that we sort of build these different platforms. My question to you is more in terms of we keep seeing these technological trends coming in. Last year it was blockchain. This year it's Gen AI, and so on and so forth. What I sort of want to understand is how do you sort of understand what is fundamental in the long term? How do you differentiate in terms of technology between what is fundamental in the long term and what's probably just hype and will eventually die down, if that makes sense?
Yeah, it makes sense. Like, how do you pay attention to all these hype cycles? Number one, most people say, I don't like all the hype. You are lying. The hype is where the paycheck comes from. As long as there's hype, you will be getting paid where you're getting paid. I promise you, when the hype goes away, like the drywall industry, there's no hype. You go to Home Depot, you buy your drywall, end the story. The hype is what keeps people excited. Whenever there's excitement, the dollars actually flow. So the fact that our industry is going through these hype cycles means that people are still excited about the technology. A lot of our hype cycles are because we know this stuff isn't finished. Stuff isn't done yet. So how do I stay consistent? At the end of the day, most of computing works roughly the same way. Data comes in, you process data, and you put it somewhere else, or you respond. We've been doing that for like 30, 40 plus years. But at the end of the day, at the highest level, there are humans doing stuff in the real world, like trading with each other, speaking to each other. And a lot of the computational things that we work on are only there to assist that. And so, for example, decision making. A lot of people are very excited about LLMs. And I was asked to be a moderator of a panel of people who created things like Watson, some of the algorithms used in some of these things. So I'm kind of out of place. But hearing them describe what they do, two paths I've seen people take. Some people like being the magician. No one understands how anything works, and you present everything as magic. And it works because no one knows anything. And then you get enterprise initiatives built around this. We have a cloud transformation initiative because you don't know how cloud works. That's how this works, and you could just be the magician. And then you have the educators that break things down to its fundamental. And I remember, I was like, you know what makes LLMs exciting? Chatbots are not exciting, by the way. But what makes LLMs exciting is that if you think about how humans interact with each other, we can give instructions to another human and get them to do things for us. So the most powerful programming language ever known is human language. We can get people to believe things. We can get people to do things with this simple dialect that we have. So the most powerful machines we've ever observed on Earth are humans. Not everyone behaves as a powerful, all-knowing machine, but you are capable of learning random tasks. We have been far ahead of all computation for a very long time. What people are excited about, in my opinion, is that we can finally take this dumb rock and teach it to interact like we interact with other computers around us all the time. for a lot of people, that is a very exciting thing. You don't have to write code in random syntax and run compilers and have it not do what you want. And so there's this excitement on the horizon that computer interaction will rise to the level of human interaction. To me, that's a fundamental thing if you understand and appreciate human interaction. So you can see the roadmap for ML and large language models is that it's infant compared to where we are as humans. So the way I find comfort in all of these new ideas, number one, I ask, what human problem is it solving? How were we doing it before this thing showed up? And typically, I find that we're only getting 5 to 10% improvements in each of these evolutions of these systems, as long as you understand the fundamentals that came before. So I never get distracted too much. You ask simple questions, and that concept I have of learning in public. I'll read the white paper, I will try a product, maybe I try to build something, and whenever I have a knowledge gap, those are where my questions come from. And when you talk to the right people that are not trying to be magicians, but they're trying to be the educator, they typically close the gap for you. And then I try to pay it forward by explaining these concepts in simple terms. So computation is something that's in the human toolbox, usually to aid human interaction.
Thank you.
I'd just like to add to that as well. I think it's important to keep up with hype, because that, as you said, that's enjoyable, that's something that keeps us going. But I think 95, 96, probably even more than that, % of businesses out there aren't focusing on that hype. They're still trying to make stored procedures work. They're still doing, moving to the cloud, moving to microservices, things that we think are really old. When did big data get used? That was 2011, 2012. That was a buzz term. People are still getting involved in that, moving towards that. I think sometimes people forget that even though we have these hype cycles, blockchain has come and maybe gone, and LLMs are now here and still going to be coming for the next few years, but people are still just trying to solve basic engineering problems like how do I do a join? And I think it's often something people forget. One of the questions that I had for you, Kelsey, was you mentioned moving to a database platform where you didn't need administrators anymore to have to rebuild indexes or manage your data platform. What else is missing from the data world or the database world that you think over the next 5 to 10 years that people are crying out for, they need and they want in their products or in their tech platforms?
I mean, right now there's a big gap between the code I write and the data that's reflected on the other side, right? Like we all build objects or types depending on your programming language, and you can look at the code and kind of understand how things work and interact with each other. But the thing we serialize on the other side can look very different. And so when you look at code in a database, how much of it has been lost because of the schema? Schemas change and evolve over time. If you're doing MapReduce, how much of the data gets dropped as it makes its way into an analytic database? And so data is very far separate from code these days. And so I think getting that relationship much, much tighter. The first time I've ever seen that relationship get tight in my professional experience was the first time I used protocol buffers to design APIs, right? Joining Google, that's just what you're going to do. But if you ever used it as a developer, you have to think about the data model up front, right? A lot of times you just build an app like JSON, HTTP equals API, right? And then you just throw a bunch of stuff in the database. But I think when you start to get closer to that paradigm where the data schema are closer in line with the actual code base, I think that's what's just missing. So how do you lead these breadcrumb trails along the way? So if I insert something into the database, what logic put it there? We don't have that today. And in the machine learning world, that's a big problem because you're making decisions. Should I give you credit? Are you allowed to go to this university? When we write if else, we can just look at the code. Oh, that's a bug. We fixed the bug. But these prediction engines, when that happens, we need to know what model, what data set was changed or trained on, and then what decision did it make. So then it's becoming more important to have this linkage between the logic and the code. And I think you're going to have to do that at some point. So today, we don't really do that. You look at data independently of the app. At some point, you're going to have to close that gap so people can actually explain how the data got there. And right now, we can't do it. So you have all these old legacy systems, and they can't change because most people don't know how it's going to affect the rest of the ecosystem, primarily the data.
Interesting. That brings us on to immutability of data, and something I never really saw before. And actually, we have versioned applications, versioned releases. We have versioning of the data in the code programming language, but really versioning of data historically, people just don't really see as a problem. My guess is, what are your thoughts? Obviously, that has implications on data storage size and everything that you need to make that work, but what are your thoughts on how people are doing that right now and how they should be doing it?
I think it's also just a limitation of our system. Storage is expensive or has been expensive for a very long time, so we mutate the data in place. We tend to get good enough results that no one complains. We delete the data and who cares, and maybe there's a copy on the backup somewhere. But this idea that you can have a version of data, I think that's new because storage is getting cheaper. So I think once storage gets to the point where it's super cheap, it is cheaper just to not delete things, right? I think there's some database designs where the reason why it's fast is because you cannot delete anything. Deletion is an expensive operation, so you just have versions, and the newest version is no response. But I think that is a byproduct of where we are with computing. So as storage gets cheaper, for example, there are some databases now that have really good tiered architecture, memory, spinning disks, SSD, and object store. And object store can be super cheap because, as you know, most data is written far more than is being read back, especially as time goes on. And so once we start to see more tiered architecture that way, I think you're going to see version data by default. One thing that kind of blew people's mind when you use something like S3 or any object store is typically versioned day one. Number one, you're dealing with a distributed system, so you need a version so that all the actors can agree on what they're reading and writing. But also from the database design, since object store is much cheaper than any other forms of storage, I think it's okay to have this kind of version concept, and it will probably be soon a best practice and probably a default as more systems add object store as a backend for the whole database structure. So I think that's going to become normal over time. But yeah, I think most people have a concept of what version of this, or you just do weird things in your database with timestamps, right? Because you have no choice.
Yeah, it leads me on to a question of the separation of storage from the compute, which you mentioned before. But before we go on to that, any other questions from the hall?
There's one there.
And one over there.
Yep.
Chuck it that way first. It's designed to be thrown.
Talk into the box. All right.
Thank you, Kelsey, for being here. I want to ask you something. As you know, that nowadays, in the tech world at least, everyone is completely in awe of coming era of AI and generative AI, right? Okay. If I were to ask you in the context of database management, do you think eventually we would be able to put in generative AI methodologies or even for management in terms of database systems? What do you think would that type of world would be like if, for example, currently we still got issues with database management or even storage current? Don't you think before that we need to like modernize our database understandings and then maybe later on think about integrating generative AI into database management?
I mean, I think people have this wild belief that, you gotta remember, I think if we have a fundamental understanding that you're predicting things, you're trying to predict how many nodes do I need in my database cluster. Based on the number of queries right now, based on my mental model of the world, I'm going to add a node to the database. There's an 80% chance that's the correct action, and maybe you just let it do it. And then it also says, you know what, I'm seeing something weird, and I predict that we want to scale to 0 nodes and delete all the data. That's my guess. And you're like, AI, baby, is smarter than me. Go do what you got to do. And now your data's gone. And someone would say, why would you do that? Well, I mean, the database predicted that we're about to go out of business anyway. Who needs all this data? That's the wrong decision. So to me, these things will only aid today human decisions. One thing you can do is just have way more capacity than you need. That's what we used to do. How much database memory do you need in this database? We need about 64 gigs, 2 terabytes of this. Right? You can hide a lot of dumb mistakes with 2 terabytes. Like, look at all these queries, they're terrible. Who cares? The meeting costs more money than the RAM. So you just skip the meeting. So there is something about over-provisioning that can hide a lot of issues. And so I think when we start to get into these hyper-optimizations, what are we actually trading off? And so I think there's a value in saying, like, I worked at a cloud provider, and the unique thing that you get from a managed service is that there's real people who know what's happening, that offer constraints, and they control all the layers. They control the network, they control the hardware, and we're seeing people get to the point where we're building custom CPUs for the use case. Remember, before we get to ML, we haven't even done the basics of optimization. If you start to say that there's a CPU that only runs Postgres, that's all it does, fast. There's a network card that only processes protocol packets for databases. Everything else, it doesn't understand. This is hyper-optimization. More than likely, we're going to yield multiples of performance from that world before some magical prediction machine about where to store data on disk. A lot of these tasks are better off, I think, in symbolic programming world. Put this on this part of the disk. We know how to do that. That domain is actually scoped down pretty low. Now, where can LLMs help people? I'm writing this application, and here are the packets that are coming in, and here are the relationships between these objects. Then, of course, we can generate the schema. Do I really need to give you all of this syntax to make a database schema if you give me this input and I have a decent model on how these relationships work? But again, that domain is so small that you might just be able to do pretty good libraries and just make that work. Active record is pretty amazing in Ruby on Rails. Whether there's scales or not, it's a different story. But I think humans have a pretty good way of approximating things from metadata. I'm just not quite sure that we need to get into the ML side of things. Maybe predicting when a disk in a database is going to fail, and we proactively move the shard because of what we know about database failures. I think that is a very interesting use case in terms of using ML to help us be more efficient. But I think that final decision should be presented to the system or the operator based on the mental model that we currently understand, and then we will make better models over time. So yeah, maybe in a few decades, our models of the world will be so good that the accuracy of these things will be so high. But I would question that model because you might be able to implement it much easier with if, then, do that. So that's just kind of my views about where ML plays a role inside of a database system itself.
It reminds me of Facebook. They've got server farms running just to train models, or just running models on how to configure RocksDB to be run in certain environments, which is insane. I mean, lots of configuration options on RocksDB, but it's insane if you think about it. I think also people are looking at how to optimize their queries. And you said this before, most people are thinking, oh, does it scale? Does it scale to Facebook? If not, I'm not going to use it. Most people are never going to get there. And and there are platforms already that already automatically using AI configure your database in a more optimized way. But most people don't actually need that, because most of the time, the issue lies with the developer. The developer's having to build a Kubernetes stack, deploy code in it, manage the SQL, and manage the application that sits on front. And most of the time, the developer is therefore creating queries, creating, not down to their own issues, but because there's so much to do, there's so many moving parts, they're introducing bottlenecks into the system without intending to. And that is, the ideal system is something that doesn't need to be tuned, in my opinion.
I think the hedge we make as developers is that we like open protocols. So one thing that has been massive success is that Postgres protocol has started to become this industry standard. I worked in Google Cloud, so Cloud Spanner started to adopt a Postgres dialect. We've seen lots of databases come out and add Postgres dialects on top. And I think people are fine with protocols because everything else is an implementation detail. Right? When people have these language battles like Rust is faster than language X, it's an implementation detail in terms of what the compiler does and what the runtime does. Syntax is at the top. So I think when we talk about does it scale, I think what most developers are afraid of is betting on the wrong technology and none of the things transfer to the next thing. So if I go all in on your protocol and it turns out it doesn't work for me, I got to start over, and that's expensive. I got to move the data, I got to do all of these things. So I think we've seen this lately, like Postgres or Prometheus for metrics. That syntax PromQL, I've seen it being implemented on top of larger systems that scale, and there is no implementation of Prometheus underneath. And so I think what people are starting to get at now is saying, hey, when we start to decouple the storage engine, the query engine, all of these things, people are hoping that there can be common protocols. I'll use the best implementation for my needs, but when the time comes, I would love to keep the same protocol on top of another implementation. I think that is the hedge that most people want. So when I hear, does it scale, I hear, am I going to get trapped in this thing and then have to do something completely different later? So scale can also be a function of reuse. Can I reuse it somewhere else if I need to?
Yeah, that brings me back to the question I wanted to ask before we went up to the audience, which is that issue of the separation of storage from compute. You see in many big data warehouses out there that they've completely separated the storage from the compute. Other people are sticking to, we are specialized in our graph engine and therefore it's all as one. What do you think the benefits, the negatives are, and what do you think we'll see more in the future between those two areas?
When I got to Google and I looked at how like Cloud Spanner and Bigtable are implemented, it's wild. Because those systems are not designed to scale down. They're only big systems. And I remember having an executive briefing with a financial institution, and they're like, hey, we want Spanner to run on-prem. I was like, how much would you pay for that? And they were like, it doesn't matter, the price. I'm like, hundreds of millions? Like, the price doesn't matter. I said, you know what, let's just entertain that thought. This would be like going to the airport and looking at the 747 on the tarmac and saying, you know what, I want that plane. And the Delta employee says, you know what, sir, you can have it right now. It is yours. You don't have a pilot's license. You don't know where to buy the fuel for a 747. Where are you going to park it? You going to drive it down the streets of London, decapitating buildings? Like you can't. Yeah, you can't. you can't operate such a system. And so when we talk about separating these layers, it's because there are things you can do once you do that. It's a much more complicated system, meaning you can have multiple dialects at the top. You can distribute the computation layers in the middle. And then I think we were giving people SLAs of 11 nines of reliability on the data part, meaning the system could be down, but there was 11 nines of guarantee that the data would still be there. So you may not be able to query it, but it's still going to be there replicated around the world. You can replicate around the world when you have a dedicated storage engine that has been optimized to do so. And then the things in the middle are just implementations of that. You can present that as NFS. You can present that as a SurrealDB API. That is that world of serverless that we're talking about, where I have this global database. And now that I have these different layers, you can do things that are just hard to do on a single system. A single system, you make a ton of assumptions about performance, for example. I know that this write is going to go to that disk. I can make a lot of assumptions when I'm dealing with POSIX that I can't make with a global network. And so I think if you can manage to scale up to a system that way, it's just a fundamental different design. But again, like I said earlier, if you keep the protocol the same, that's where the magic comes from. Ideally, we don't leak these details to the end user. And so I think that's the beautiful thing about making sure that the protocol is very explicit and independent of the implementation, then you can go far. I mean, the best protocol I've seen, you can debate whether it's a good protocol or not, but HTTP. HTTP has so many implementations in the world that you can go from a standard library implementation of HTTP to Envoy or a cloud provider's massively scaled system that runs on tens of thousands of servers. But the protocol is the same. And so I think that's what you get when you start to decouple these layers. Let's separate these protocols from the implementation. And I think you just end up with a more powerful system, or it can grow into power over time.
Interesting. We had another question over there, which we'll jump to.
Question over here. Who has the
Who's got the mic box?
Throw it over there. Let's see how good your aim is. Someone throw
Throw
the
that
box.
way.
Yep. Pretty not great. All right. Engineers, come on. All right.
Nice. So where do I talk?
You talking to the box?
To the back bit.
To the box. I'm talking
Yeah.
to the box. Fantastic. That's the day I was living for. So I have a question probably more to Toby. I'm lucky enough to work with quite sophisticated systems. We can deploy to the edge all over the world, different regions. Our system work on top of framework that transcends HTTP. It's fully stateful on the client, on the server, over WebSockets. But we have one instance of PostgreSQL. I mean, it's a cluster, right? It's reliability, highly available. But from any part of the world, it travels to the, to this one location where it's hosted. And it's basically, a distributed pumpkin. because we are bound to latency, because PostgreSQL cannot really, it was not built to be a distributed system. And when I'm looking at this landscape, I see MySQL, Postgres as a dinosaurs. And I'm praying, for a comet, to land of them one day, and people and developers will be liberated from being part-time DBAs, as Kisli said. So my question to you, how are you going to become that comet?
No pressure.
Yeah, no pressure.
I think to answer, look, I'll try and answer that question. I think it also relates to, I'm going to fob this over to you as well, but I think it also relates to what you were saying, which is about that geolocation boundary of data. And you look at databases like Spanner and CockroachDB, and they're doing this, where you can say, I need this data to reside there, which is an interesting topic. So I'll let you talk about that in a sec. But for us, it's about amalgamating different technologies together in order to enable that in the future. So today we launched change feeds, and that will enable us to sync different parts of the database or different specific tables to different areas asynchronously. So you're able to, you can never build a system that has the same ping time or connection time across the world, because somewhere, either that data has to sync up or someone has to be in control of that data, right? So you have to balance it. You have to say, look, certain users or tables can sit over this part of the world, certain tables can sit over this part of the world, and vice versa, and we can sync between them. So the asynchronous aspect is between those tables, but they're always consistent at a certain point. As a developer, you have to choose. Now, you can go down the asynchronous route, CRDTs, as you said, fully stateful to the client. I'm not sure how you're doing that. That gives you the ability to see changes instantly and to have everyone writing and reading and updating documents at the same time, but you've got the other aspect that now you're having to do that asynchronously and ensure that if someone wrote at the same time, are those updates conflicting? And not in the sense, obviously, CRDT solves that, but are they conflicting in terms of the business logic? Is that person allowed to update that at the same time if that person has already updated that record? And that's what CRDT doesn't yet solve. So I don't think I can quite answer that question just yet, but I think putting these different technologies together, being able to run, first of all, distributed in a single location, a single data store, so that you've got that highly available aspect, that gives you more nines, I guess. And then being able to say, look, we can run multiple clusters, which using the syncing between those gives you the ability to query really quickly from a more local perspective. But if you're still writing and you want that data to reside in the US or Europe, and you're operating this from Asia, then you're going to have to deal with that slowness. But it's about having all of those different technologies put together so that you give the developer the choice to decide how they want to or can implement that, I think. But yeah.
Yeah, I mean, you still have to deal with the laws of physics too, right? So the one cheat that, if you think about like how something like Spanner is implemented, as a developer, you're given a URL, and you can have a multicast IP that makes that URL resolve pretty fast. So if you're in Australia, you hit that URL. If it's a read, Spanner makes a guarantee of 7 milliseconds between everything. And it uses logical clocks, atomic clocks, to deal with the span of time, speed of light, all of these things. So when you write, you're forced to go to a single writer for consistency reasons. You go to that single writer, and before it's committed or said it's been written, there's some guarantee that this thing, within 7 milliseconds, will be everywhere else. Now, you can do that when you can control the network. We have our own underwater sea cables, et cetera, et cetera. But you can have a protocol that says, given this timestamp, within 7 milliseconds, it's safe to write everywhere else. We don't have to go do this multi-phase commit with all the databases and communicate, because we can just use time. Worst case, 7 milliseconds at a timestamp is the upper bound. So you know as a developer, within 7 milliseconds globally, the data is going to be consistent between their initial writer and everywhere else. So then the problem becomes a declarative one. We don't have a lot of data orchestration systems. If you think about most cloud offerings that they say, hey, it's a fully managed database, they're talking about like the database binary, but a lot of orchestration on top. So you as a developer, what you really want is to say, give me a URL, and we need a router tier in between that and the database. Today, we're hitting the database directly. There is no logic ahead of us to say, you're a client and you're doing a read operation. This read operation is safe to go there. If I look at the query and you tell me that you're okay with data that's slightly stale, fine. I will route you to a database knowing it hasn't been, or you know that it will be 7 milliseconds before you see everything else. So you have this routing tier. But then the declarative nature will be something like, imagine creating a database. Today, databases make an assumption that it's all in one system. Database schemes will have to evolve to give clues to the orchestration layer. This database, this data set is allowed to run in Germany or these other geolocations. And so when the data is written, then it's only replicated where you need. So you're not replicating data you don't need in certain places for regulation. That way, when the client comes and makes that query, you know the data is going to be there. Right now, we don't have a lot of database orchestration systems in the wild. But I think cloud providers have done this via managed services. What we need to see in the open source world, right? Postgres is like download it, run it yourself, and glue those layers on top yourself. But I think what you're asking is that we need to get to a point now where we understand that database systems need to be managed and data needs to be orchestrated, just like compute gets orchestrated. That will come once people realize that that's a gap. So keep asking that question, but I think we already know how to do this for applications. We do it all the time. Data needs to operate the same way. So data orchestration is the gap we have once we start to have really great, solid databases.
So that brings me on to another question. You mentioned the word edge there. I guess we've seen compute move towards the edge, and that's a big topic. How far do you think data should go towards that edge, or how far do you think it should stay away from the edge?
Let's use a hypothetical. You're Spotify. You have this catalog. If you put that entire catalog in US East, and everyone in the world that wants to listen to music has to stream from US East, the people in New York will be fine. They're like, this is great. The people in Australia would be like, this is the slowest thing ever. It takes at least 1 or 2 seconds for the song to queue up, right? So what would you do? One idea would be to just copy all the data into all of the regions, right? And for a lot of people, that's going to be the speed up you need to run pretty fast. The next thing you can do is cache. Would you put it in Redis? That's silly. It's a blob. Where do you put it? You put it on the device. So as the device gets bigger, you put it there. And I think the other thing is data orchestration. These apps are starting to do that. If I know you're listening to hip hop, and I know that a new hip hop artist has come out with a new album, I can preload the data on your device whether you listen to the song or not. As long as you allow me to have a certain amount of space, I can start pushing things that you will watch. If I'm Netflix, I'm going to put the 3rd episode much closer to the device. If you have an Apple TV, there's a bit of storage there. Maybe I'm allowed to use it. Or maybe there's a colo nearby. I'm allowed to use it. So this data federation, ideally, if you're writing an app, you should probably start making more logical decisions. I think the world of SaaS has poisoned people's thinking around this. Why do you want data that you can lose and get into trouble? If you are making tax software, do you really want my personal information? That is a liability. So we're coming from a world where it was always edge. My desktop, download software, everything stays on my desktop. This idea of building multi-tenant services at scale, that is super hard. It's hard to secure it all. And we might find ourselves going back into a world where we just leave the data where it's most appropriate. I really don't need your address. I don't need your social security number for my tax software. That can stay on your machine, and we will send the forms to the right company. And also, it's getting expensive. Once VC money dries up and people realize that you actually have to make money when you're building these systems, you got to put a lot more thought into data. Like, remember when Docker used to have free image storage forever? Then they sent that email like, hey, if you're not paying, we're not going to have unlimited Docker images being stored because it makes no sense. So you need to store that in your own registry. So I think people are going to get a lot more clear about where data actually needs to live. I'm actually betting that our devices will get bigger over time. At some point, there will be an iPhone that probably has 2 terabytes of data as the base install. Then it will probably make sense to pre-cache as much of this stuff that makes sense on the local device so you can have a great experience. If you watched the Apple keynote the other day, they put a lot of the Siri models on the device. So it doesn't have to connect to the web to do basic things like infer what you're saying. So I don't think we're going to go backwards from that. So I think the edge is the realization that our hardware is getting so good, our networks are getting so fast, that when you combine the two, it makes sense to use all the computers at our disposal. The cloud was a remix of the mainframe, everything in the cloud, dumb terminals on the side. I think people are going the other way. For performance and usability, we're going to start putting more back on the device.
Interesting. Do we have any other questions from the hall?
So kind of going back a few conversations ago, you mentioned being just a database, being a DB service, being a DB platform. In terms of like the short, the medium, and the long-term look ahead, where do you see yourself focusing?
It's a great one. We get asked a lot because we have so much functionality. We always want to be considered a database, and then that's what we're striving to do, right? We care about the performance. We care about the performance of queries. I think the term database has been put into this place where people just think that deals with data. Actually, database means handling data, right? So anything where you're handling data, connecting to query that data from the clients, everything like that. But at the same time, we want to offer that functionality so that it simplifies developers' lives, but we don't want to move away from the fact that this is something that sits at the core of an application platform. This isn't 16 different services running in the cloud that you can connect to. This is a single binary that can be downloaded and used yourself. And it sits at the core of everyone's application. So in order to be that, and let's call that a database, we have to be performant. And I'd say the difference between a software as a service platform or a data layer or an API and a database, I think is down to the functionality, the querying functionality, and the performance. What do you think about that?
Yeah, I remember the first time I imported SQLite just to do something in my app that I didn't want to use the file system for. Right? It wasn't to try to replace my main database. It's just that it was much easier using SQLite and SQL to query for objects than like searching the file system. And that was a complement to what I was using for my system of record. So you can imagine grabbing a bunch of data from that system of record, but I need to manipulate it even further. In many ways, I was using SQLite like an in-memory cache with a much more powerful interface than you got from a normal key value store. And at least the way that I saw SurrealDB, it can run embedded, it can run as a standalone server, and I can imagine some people doing a bit of both, right? Because we saw in the presentation that you can feed in this model. Without having even used the system, I can imagine how that's going to work. Some people have a bunch of models that they should be using at runtime. As my application starts, I can import the model that I need, use that in process, and then use the data that I choose to store in that object representation in memory to make predictions. Might be faster than trying to go find out what library I should be using from another dialect. And I can see a developer just saying, we're using MySQL for everything else. And I'm pulling in, I don't know, 200 rows, but now I want to do this ML stuff based on the data I got from MySQL. I might not be able to convince the entire enterprise that we got to move to SurrealDB. That can be a big, heavy lift. But if I can just import it into my app, and then now import that data in memory, and just start using these ML capabilities as a library, I can see that going really, really far. And there's a lot of value there. I can turn that into a normal data abstraction layer for the other teams, and they may have no idea that SurrealDB is even involved in being able to do these kind of things. And then maybe we go and complement MySQL later. So the way I'm looking at it today, it scales way down, which is a benefit to developers. And I think it's really healthy to think about complements when we think about tech versus wholesale replacements. So to me, the value is that there's an entry point that doesn't require rip and replace.
I've got one last question. This has been very insightful and incredible, to be honest. But what would you want to see in SurrealDB that we don't have? What do you think we should be looking forward to in the future?
All the startups I've worked at, the best features came from people that are doing real things, like the question you had around data orchestration. That doesn't exist today. We don't walk around and say data orchestration. And so one thing I would do on the future roadmap is figure out how do we make data orchestration feel like the magic you showed in the keynote. I think a lot of people saw the keynote and was like, oh my God, I finally know what to do with all these ML models we're producing. That's going to go a long way for a lot of people. But if I can give the same data orchestration into the schema design, thinking about there's this relationship between my data, the schema, and the infrastructure, I would probably look on the roadmap and add another row. What are we doing on the infrastructure side? Maybe we should invest in data orchestration so I can start to say things like insert into where country equals Germany, and then have metadata to decorate that data, because then it's much easier to do security compliance, it's easier to do backups, it's easier to do some of these use cases that I think are still a pain point that I think most people don't even know how to describe, because typically a DBA will hide it, or they're using some managed service to do the rest.
Yeah, interesting. Well, we're at the end of our time now. This has been amazing, and thank you also for the questions from the audience. Kelsey, thank you very much. Kelsey Hightower, everyone.